Nibagiwe kuyifungura. Hello, my dear friends. Welcome back again to our YouTube channel, Learn Maths. Now we are going to continue with integration. Last time we were on rational function, integrals, rational function integrals. It was of the case the integral of h of x by gx dx. We saw when the power of denominator is bigger than or equal to the power of the numerator. So here the power of the numerator is greater than or equal to that of denominator. What do? We do a long division, and then follows the laws that govern integrals. At this time, we are going to deal with when the power of denominator is bigger than that of numerator. That of numerator commit the integration by partial fraction. Partial fraction. This is where we are going to focus. So integration by partial fraction. The integral of the case here ux by ax squared plus bx plus c dx. But the power of this ux is less than the power of this denominator. Case 1, we are going to see if ax squared plus bx plus c can be factored, factored, factored as a product of two linear factors. Say ax squared plus bx plus c as ax plus b into cx plus d. What we do, the integral becomes ux by ax squared plus bx plus c dx. This is the integral of a by one of these factor, let's have ax plus b dx plus the integral of b by dx plus d dx. Here the question is, how do we get these values a and b? I mean the uppercase letters a and b. By the cover up rule method. A can be equal to the limit. We take this and consider this. We have ux divided by this, because this was hidden, dx plus d. And here we equate this ax plus b. Means our x is approaching minus b over a. And b is got by taking the limit as x approaches. We hide this and consider this with this here. Here is ux by ax plus b, and here this goes to 0, x minus d by c. Okay. Let's continue with our reason by examples. Example 1. Integrate by, let's have x squared minus x minus 2 dx. Can we let this as a factor of two linear functions? Look, ax minus x minus 2 can be factored as x plus 1 into x minus 2. Here is the factor form of this. Now, let's continue by the integral of 1 by the factors are x plus 1 into x minus 1 x. As you see, this can be the integral of a by, we have this x plus 1 dx plus the integral of b by, here is 2 guys, x minus 2 dx. So the question is, how are we going to get a by a? our a value is going to be, let's have limit of, here we are going to hide this and consider the remaining part. Here is 1 by x minus 2, and because this was hidden, we need to equate it to 0. When equating this to 0, x plus 1 to 0, our x will be minus 1. That's why here x is approaching minus 1. Okay. This is 1 by minus 1 minus 2, and it's by minus 1 over 3. What about b? As I told you, because you have x minus 2 here, we are going to hide minus 2, but here we hide this, we'll be staying with 1 by x plus 1. That's why this is the limit of 1 by x plus 1. As x approaches, this was hidden, need to equate it to 0. X minus 2, which is 0, our x will be 2. That's why here x is approaching to 2. This 1 by 2, 1. And this is 1 over 3. Now, let's integrate. We need to have the integral of 1 over 3 by x plus 1 dx plus, but here is minus because a value was minus 1 over 3 plus the integral 1 over 3 over x minus 2 dx. This is going to be, with this number out of the integral sign, to be minus 1 over 3 times the integral of 1 by x plus 1 dx plus, take this 1 over 3 out of the integral sign to have 1 over 3 times the integral of 1 by x minus 2 dx. This is going to be, as you see, this is of the type we have seen in our last. Having the derivative of this, if to give this the ln of the denominator, hence this is minus 1 over 3 times ln of x plus 1 plus 1 over 3. This, the derivative of the denominator gives 1. That's why here we have ln of x minus 2 plus 0. Therefore, the integral 1 over x squared minus x minus 2 dx is equal to minus 1 over 3 times ln of x plus 1 plus 1 over 3 times ln of x minus 2 plus a constant of integration. Yeah. We are going to continue with question. Example 2. Can you integrate 1 over x squared minus 4 dx? Yes, you can. Let me show you how to do it. X squared minus 4 can be factored as x minus 2 times x plus 2. Here is the factor form of x squared minus. Okay. The integral here is 1 over x squared minus 4 dx is equal to the integral 1 over x minus 2 times x plus 2 dx. And this is the integral of, let's have a by x minus 2 dx plus the integral of b by x plus 2 dx. The question now is, how are we going to get these values a and b? Here a will be, because the denominator of a is x minus 2, we are going to hide this x minus 2. Okay? Now, limit, we add the left. We have hiding this, we stay with 1 by x plus 1, x plus 2. And equate the hidden 1 to 0. That will be x, which is 2. That's why x approaches 0. And this is 1 over 2 plus 2, which is 1 by 4. B value will be given by the limit x approaches, because the denominator of b is x plus 2, we need to hide here x plus 2. We'll be staying with 1 by x by x minus 2. Because we had this, we need to equate it to x plus 2, which is 0. Our x will be equal to minus 2. Suppose minus b value is going to be 1 over replace 2 minus 2. This is minus 1 over. The integral will become the integral of 1 over x minus 4 dx is equal to, our a value is 1 over 4 by x minus 2 dx plus the integral. Our b value is minus 1 over 4 divided by x plus 2 dx. So we need to take the constants out of the integral sign to be 1 over 4 times the integral of 1 by x minus 2 dx minus 1 over 4 times the integral of 1 over x plus 2 dx. Now, this is 1 over 4 times the natural log of x minus 2. It's 1 over 4 times the natural log of x plus 2 plus a constant. And as you see here, we can factor 1 over 4. Even here, we factor by minus 1 over 3. Minus, it's 1 over 4 times ln of x minus 2 by x plus 2 plus a constant of integration. This is the integral of 1 over x squared minus 4 dx. Guys, we can continue with our course. Okay, let me look for the place where to continue for. After this, I'll be giving you some examples, and they'll be like exercise. Let us acquaint this part. Because you are here, it looks like you are my friends. What I want from you now is to share the video, and your part is to subscribe. If you have any question about integration, please please leave it in the comment section so that our next time we'll be dealing with the question of your post. Okay. And we wish want to be done by you. The next example is about the integral of x minus 2 by x squared plus 2x dx. Here is the next example. Let's take it as exercise A. This is B. We have the integral of x over the square of x plus 2x plus 2 dx. 3. C. We have the integral of 2 by x squared minus 1 dx. E is about the integral of 2x minus 3 divided by x squared minus x minus 2 dx. We are going to do 2 examples of those, and the next one will be done by you. For you, let's try it. Make sure we have understood the course. Now, let's answer A. Answers A. The integral of x minus 2 by x squared plus 2x dx. This is the same as the integral. Here we have x minus 2 divided by, we are going to factorize by x here because this can be factored. X into x plus 2 dx. Okay, as you see, we see the factor of this is this. So, this is going to be the integral of a divided by x dx plus, here we can find the value of x. That's why here b having b by x plus 2 dx. Okay? Now, the question is, what is the value of a? The value of a will be given by the limit as x approaches. As I told you, we are going to add this x and we'll be letting x minus 2 by x plus 2. Here is x minus 2 by x plus 2. And because we hide this, we need to equate this to 0. This x will be 0. As x is 0, here x will be approaching 0. And this is 0 minus 2 divided by 0 plus 2. Here is minus 2 over 2, and this is minus 1. What about b? Is going to be the limit of, we are going to hide, because b is this, its denominator must be hidden from this. Okay, we hide this and we write x minus 2 divided by x. Here is x minus 2 by x, and when equating this to 0, our x will be equal to minus 2. That's why here x approaches minus 2. And this is going to be minus 2 divided by minus 2. This is minus 4 by minus 2, and this is 2. So the integral of x minus 2 by x squared plus 2x dx is going to be, we are going to replace a here by minus 1. That's why here we have minus 1 by x dx plus the integral. Replace b by minus 2 by 2. Here is 2 by x minus x plus 2 dx. And this is minus the integral of 1 over x dx plus 2 times the integral of 1 by x plus 2 dx. This is going to be, here is the integral of x minus 2 by x squared plus 2x dx. This is going to be, what is this? It's minus ln of x plus 2 times ln of x plus 2. Here we are C. This is the answer to the question A. Let's even try B. You're going to try B, guys. Question B is, our B is about the integral of x by x squared plus 3x plus 2 dx. Do you think we can factor x squared plus 3x plus 2? Yes, we can. The factor form of x squared plus 3x plus 2 is x plus 1 times x plus 2. Okay, that's why this integral is going to be x by, instead of writing this, we are going to learn this. Here is x plus 1 into x plus 2 dx. And this is going to be the integral, because this can be equated to 0. Here we are going to have a over x plus 1 dx, adding b, the integral of b over x plus 2 dx. As we saw, the question is, how are we going to get A and B? Here A will be given by the limit. Because A has this denominator, we need to hide its denominator here. Let's hide it. We stay with x by x plus 2. Here is x by x plus 2 of x approaches. If the top is 0, our x goes to minus 1. And this is minus 1 by minus 1. This is minus 1 over 1, and that is minus 1. Let's do the same for b. Because the denominator of b is x plus 2, we are going to hide x plus 2 here, and we stay with x by x plus 1. We have limit x by x plus 1 of x approaches. If this goes to 0, our x will goes to minus 2. Here x approaches minus 2, and this is minus 2 over minus 2 plus 1. That is minus 2 by minus 1, and this is so the integral of x by x squared plus 3x plus 2 dx will be, we are going to replace a by minus 1, the integral of minus 1 over x plus 1 dx plus the integral, our b is going to be replaced by 2 of x plus 2 dx. We need to take this minus 1 out of the integral sign. This is going to be minus 1 by x plus 1 dx plus 2 out of the integral sign. You stay with 1 by x plus 2 dx. And this is minus the natural log of x plus 1 plus 2 times the natural log of x plus 2 plus the constant of integration. Hence, the integral of x by x squared plus 3x plus 2 dx will be minus natural log of x plus 1 plus 2 times plus 2 plus a constant. It can also be following the properties ln A by B, which is ln A minus that of B. This can be ln of the square of x plus 2 divided by x plus 1 plus constant. The remaining two questions, C and D, must be your task. You need to try them to see whether the lesson was well understood. Let's continue with the next. We are going to have a note and I'll be letting it for you. If the factor ax plus b occurs n times, in the denominator, of a proper fraction, then their corresponds a sum of n partial fractions of the form letter v a1 by ax plus 1 plus b, plus a2 by ax plus b square plus a3 by ax plus b plus 3. Continue this way to an by ax plus b to the power n. Okay. If the denominator contains an irreducible quadratic equation, what do we do? This is to say, if ax is plus b plus c cannot be written in a factor form of two linear vectors, the partial fraction for it can be expressed as ax plus b divided by the ax square plus bx plus. Let me show you one simple example. Let's integrate 1 by x squared minus 8x. We know that a power 3 minus b power 3 can be factored as a minus b into a squared plus ab plus b squared. So here x power 3 minus 8, we know 8 is 2 to the power of 3. This is x minus 2 into x squared plus 2x plus 4. 2 power 2, that is 4. Okay. The integral can be written as 1 over. Instead of writing this, we need to let it factor form, which is x minus 2 into x is 0 plus 2x plus 4 dx. This is the integral. Because this can be equal to 0, I mean x minus 2 can be equal to 0 to get x, which is 2. We need to write a by x minus 2 dx plus the integral. Because here we have x squared plus 2x minus 4. Its discriminant will be 2 per 2, that is 4, minus 4 times 4, that is 4 minus 16, that is minus 12. And its square root doesn't exist in the set of real numbers. That's why this is an irreducible quadratic equation. In this case, we need to take it like this. Because here we have a, we need to start from b. Here is bx plus c divided by all of this. Here is x squared plus 2x plus 4 dx. Okay. Now, as I told you, because here we can find x is 2, we need to have 1 by x minus 2 x squared plus 2x plus 4. This can be a by x minus 2 plus bx plus c divided by x squared plus 2x plus 4. Now, what is a? A can be, but before finding a, I do want to this put them on the common denominator, where this will be multiplying this and this multiplies this. Here is a into x squared plus 2x plus 4 plus, we need to have this x minus 2 into bx plus c. This must be equals 1 because the denominator will be the same. That's why the denominator will also be the same. So I can have a as the limit because the denominator of a is x minus 2. When taking this x minus 2 0, or x will be 0. That's why x is equal to 2. Our x will be 2. And we hide this. Hiding this, we stay with this. 1 over x squared plus 2x plus 4. This is 1 over 2 per 2, that is 4, plus 2 times 2, that is 4, plus 4. This is 1 by 12. That is a value. So let's have 1 by 12 here. Means 1 by 12 into x squared plus 2x plus 4. Let's multiply here. X times bx, that is x per 2, plus x times c, that is cx, minus 2b x plus minus 2c. And this is 1 because here is 1. We got a value, we need b value. Okay, let's multiply 1 by 12 inside here. We have 1 by 12 x squared plus 1 by 12 times 2, that is 1 over 6 x plus this times 4, that is 1 over 3 plus bx squared plus cx minus 2b x minus 2c, and this is equal to 1. we are going to sum stuffs with x power 2. Here we have b plus 1 by 12 times x squared. Those with x, the coefficient of x. Here is plus, we are going to have, here is 1 over 6, plus c minus 2b. Okay? Here is x, here x, here x, times x. So add the term with the terms independent of x. Here is 1 over 3, which is this, minus 2c. Okay? This is going to be 1. Here the term in x is 0. The term in x squared, that is also 0. But the independent term of x is 1. That's why this term is going to be 0. And this one will be 0. Because this is sufficient for us to be, and this is sufficient for us. Okay. Here we have b plus 1 by 12. This is 0. It's equal that b is minus 1 by 12. Okay. And here we have 1 over 3 minus 2c, which is 1. 2c is going to be 1 over 3 minus 1. 2c is equal to minus over 3. Here c is minus 1 over 3, guys. That is the values we need. We have this. We have this. And we know what a is. We know what a is. Our a value was, I guess, 1. What was it? Our a value was this. Here a value is reciprocal of 12. Back to our integral. The integral of 1 by x power 3 minus a dx is going to be the integral, because here we have a, we are going to take it here. That is 1 by 12 divided by x minus 2 dx plus the integral. We have b as minus 1 by 12. Here is minus 1 by 12 x. C is minus 1 over 3. Minus 1 over 3 by x squared plus 2x plus 4 dx. Let's multiply and divide 12 here. This is going to be 1 by 12 integral of 1 by x minus 2 dx. Let's multiply minus 1 by 12. Yeah, take minus 1 by 12 into, we stay with 4x. Okay. Sorry, we stay with x plus 4 divided by x squared plus 2x plus 4 dx. Because here, derivative of this will be 2x plus 2. We need to multiply 2 here and here. This is going to be 1 by 12 times the natural log of x minus 2. These two, we multiply this, minus 1 by 4. The integral of 2x plus 8 divided by x squared plus 2x plus 4 dx. This is 1 by 12 ln of x minus 2 sorry, 2x plus 2 plus 6. Here is 2x plus 2 plus 6 by x squared plus 2x plus 4 and group this dx. This is 1 by 12 ln x minus 2 plus, sorry, here is minus 1 by 2, 4. Let's have 2x plus 2 divided by x squared plus 2x plus 4 dx, then plus the integral of 6 by x squared plus 2x plus 4 dx. You see, about here is minus 1 by 2, 4. So as you see, the derivative of this stuff is, that's why the integral of this will be the natural log of this denominator. That is, we have 1 by 12 ln of x minus 2 minus 1 by 2, 4 ln of x squared plus 4, 2x, sorry, plus 4 minus, take this 6 here, we'll be having minus 1 over 4. The integral of 1 by, completing the square, you see this 4 is 1 plus 3. That's why here is x squared plus 2x plus 1 plus 3 dx. And from our last class, we saw the integral of 1 by x squared plus a squared dx. This is 1 over a times tangent inverse of x over a. Okay? This is going to be 1 by 12 x minus 2 minus 1 1 by 24 ln of x squared plus x plus 4 of 4. 1 integral 1 plus so here the square of x squared plus 2x, the square of x plus 2x plus 1, that is the square of x plus 1 plus 3. As you see, 3 will be seen as the square root of 3 for 2. In order for this to be of this form, where x will be replaced by x plus 1 and a by the square root of 3. Okay? The given integral 1 by x power 3 minus a dx is going to be 1 by 12 ln x minus 2 minus 1 by 24 ln of x squared plus 2x plus 4. So plus minus 1 over 4 times 1 a, our a is equal to 3. This is 1 by the square root of 3 times arctangent of x is will be replaced by x plus 1 by the square root of 3 plus a constant of integration. So here is the integral of this reciprocal of x power 3 minus a. Okay, to this question, I hope you're getting one secret which is hidden there. I'm going to give you some exercise so that we can end up this course. Exercise, guys. Let me have your screen. Exercise for you. Exercises evaluate. A. The integral 2 by x squared minus dx. B. The integral of x by x squared plus 3x plus 2 dx. C. The integral of x minus 3 by minus x to 2 plus 2x dx. D. The integral of x by x squared plus 2x plus 1 dx. The next one, E. The integral of 3x by x squared minus 4x plus 4 dx. EF is the integral of 8x2 minus 19x divided by x to 3 minus 3x to 2 minus plus 4. Okay. These are partial fraction integrals. When the A stuff on denominator contains an irreducible equation that repeats itself n times. It will follow the rule that we have here. Here will be ax plus b, a1 x plus b1, a2x plus b2, a3x plus b3, like that. Okay. If the denominator contains a quadratic factor, denominator contains a quadratic factor, Okay. For this, to evaluate integrals of this kind, what we do is to complete the squares. We complete the squares. I hope you know it. As ax squared plus bx plus c is 0. So this is why. Let's go try. Completing the squares, we need to divide a everywhere. So that here y is going to be a into x squared plus b of x plus c over a. To complete the squares, what we add there? We add and subtract the square of half of this. Okay? Add e. Sorry, let e be a half of b by a. So e power 2 will be b squared by 4a squared. This is what we add here and subtract it. Here, y is going to be a into x squared plus b over ax plus, let's have this e power 2. E power 2 and subtract it plus c over a. This is going to be a into, we write x plus e for 2 plus, what is this? Okay. Minus b squared by 4a squared plus c over a. This is a into x plus b over 2a for 2 minus b squared minus 4ac by 4a for 2. Remember, this is the discriminant. So here, what looks like the product of a into x plus b by 2a for 2 minus delta by 4a for 2. Here, it's simply, when dealing with integrals of those kinds, what we do is to complete the squares, guys. We need to have one simple example. A simple example. Okay. An example which is simple. one simple example. Example, find the integral of 1 by x squared minus x plus 1 dx. Let's together. Hope this is easy. It's easy for me, and I hope it will be easier for you also. Now, to continue with this, we need to complete the squares. Complete this is x squared minus x plus 1. As I told you, we take this coefficient and divide it by 2. This square will be, so E is going to be, we take B over A, our B is minus 1, and remember we multiplied a half. This is minus 1 over 2, and its square is 1 over 4. This is what we are going to add. This is the aspect we are going to add equal to, which is 1 over 4 minus 1 over 4 plus 1. This is going to be, we have this. When having this as it's here, we stay with x plus e, and our e remembers minus half. This is going to be x minus 1 over 2 raised to 2. On the common denominator, here is minus 1 over 4 plus, because you have 4, 1 is 4 by 4. This is going to be x minus 1 to 2, minus 1 over 2 raised to 2. Here we'll be having 3 over 4. We know something about a squared plus a squared when dealing with integers. Okay. This, in this form, will be looking like x minus 1 over 2 to 2 plus the square root of 3 over 2 to 2. This one gave this. As you see, when dealing with integrals, we know 1 by a squared plus 1 by x squared plus a squared, because addition is commutative, is given by 1 over a times the inverse tangent of x over a plus the constant of integration. In our case, our x is this, while our a is this. Okay. The integral is therefore the integral of x squared minus 1 over x squared minus x plus 1 dx is equal to 1 over our x is this. Here is root 3 over 2 times arctant of x stands for x minus 1 over 2 divided by a, and our a is root 3 over 2 plus c. This is the same as 2 by root 3 times arctangent of, on common denominator we have 2x minus 1 divided by the square root of 3. The common denominator here will be 2, and this 2 will be simplifying this one, plus a constant of integration. That is one of the examples. Okay. Let me give you some exercise about this. Do you have here? exercise. The integral of the square of x plus 2 by the cube of x minus 1 dx. This is 1. 2. The integral of 1 by 6x to 2 minus 5x plus 1 dx. Right? Is about the integral of 1 over the square of x plus 2 dx. The next one is 4. The integral of x by 9x squared plus 6x plus 2 dx. 5 is the integral of 6x to 2 minus x plus 5 divided by the product of x minus 2 and 2x squared plus 1 dx. 6, which seems to be the last question, is about the integral of x plus 1 into the square of x plus 2 dx. This is the end of our drive. Before leaving this class, I want you guys subscribe to my channel. Remember that your like, your share are very crucial to me. If you have any questions, please write it in the comment section, so that next time we'll be dealing with that. I want you to try these questions I gave you as exercises. Bye bye. Patron.